Hi, I'm Neel.
Go.
Hi, I'm Alisen.
This is our Mastering Electronics final project. It is a human voice detector, which means this LED goes off when a human speaks into this microphone, this electric microphone, and it also picks up any signals within those bands of human speaking.
This is our schematic. First, we have the microphone input modeled by the voltage input here. And then we pass through two passive filters, a low pass and a high pass, to create a band pass filter. And then we amplify it with op-amp circuits, and then we put it through an active filter to amplify it further and filter it further. And then we have a Schmidt trigger to turn it into a square wave so that it flickers instead of is an analog. And since the Schmidt trigger is an inverter, we re-invert it with the BJT.
First, we start with our microphone measurement circuit. As you can see, over here is an electret microphone. To power the microphone, we're sending in 3 volts through a potentiometer. We used a potentiometer so we could vary the resistance to optimize the microphone output. This is followed by 1 microfarad capacitor to remove any DC components from the microphone and center the wave around 0. After this, we filter the signal through an RC low pass and a CR high pass filter cascaded to create a band pass filter. After this, we then put it through an op-amp through two series amplifications. The first amplification has a gain of 121, and the second one also has a gain of 121. This creates a 14,641 times gain of the original electret microphone signal, and because most of our inputs into the microphone through our voice is mostly through millivolt waves, so we really need to amplify it for it to light up an LED in the end.
After that, we have the active bandpass filter, which is after the op amps to prevent any noise from powering the LED. Here, our low pass and high pass bands are 252 Hertz and 89 Hertz to simulate the frequency voice range of a human. Our gains are 1.62 and 1.23 for the active op-amps filters. We then put it through a Schmidt trigger, which turns it into a on or off signal to power the LED so it flickers when you talk into it. And since the Schmidt trigger is an inverter, we have to re-invert it with the BJT inverter.
Here is a demonstration of our circuit in action. For every word I speak, it simply flickers. However, if I go to frequencies that a human voice cannot imitate, such as whistling, you can see that the LED does not light up when I whistle. This is because the human voice does not go to such a high frequency.